Determine if the system is consistent. That means if there is at least one solution. Okay, we know that when we have a system of equations, linear equations, we can have no solution, that is inconsistent system, or we can have one solution or infinitely many solutions, that is consistent. So here we need to check if this system is consistent. Do not completely solve the system. That means we don't have to find the exact values of x1, x2, x3, x4. There are 4 variables. So first we're gonna write down the augmented matrix. Okay, so the matrix of coefficients and the last, these are constants. So 1, so x1, x2, x3. So first look at here, first equation, there is 1, no x2, no x3, so we can put 0, 0. For x4 is -2, and finally -3. Okay, we can put colon here, not needed. For the second equation, there is no x1, so 0, 2, 2, there is no x4. Oh, it's kind of given nicely, so 0, 0. Third equation, first 2 variables are absent, so 1, 3, 1. Here -2, 3, 2, 1, and 5. Okay, this is the augmented matrix of this system. Now our goal is to make there is some type of number, and here 0 and something. Okay, this is good, and 0, 0, 1. Oh, this is also good. So we want to make this triangular matrix. So we want to make 0, 0, 0, and we can have any number here. First 3 rows are good. Okay, it's already triangular, but we need to make this 0 using elementary row operations, and then this 0, then this 0. So, and we can have some number here. Okay, so we're gonna work on R4. Let me write on R4. So that means R4 plus, to make this 0, we multiply R1, because that's the easy one, H1, multiply by 2, R1, so this will be 2 plus -2. -2 plus 2 will be 0. Okay, so we do one at a time. That makes, so we are only changing R4. So first 3 rows are same, 1, 0, 0, -2, -3, 0, 2, 2, 0, 0, 0, 0, 1, 3, 1. Now here, okay, we need to do this work. -2 plus 2 times 1, 2, that is 0. 3 plus 2 times 0, which is 0. 3 plus 0 is 3. 2 plus 2 times 0 is 0, so just 2. 1 plus, let me write it, 1 plus 2 times -2, -4. 1 plus -4 is -3. Okay, and 5 plus 2 times -3 is -6. 5 plus -6 is -1. Okay, so we are able to make at least this one 0, the first 0. Next we need to make this 0. So we are still working on R4. That's the row 4. That's where we have issue. Okay, and that is R4 plus. Okay, we can take help of second row, because there is a term here, there is 0, so no help. So okay, it's not that easy, because 2 and 3. So to make this 0, okay, we can multiply this by 2 times, let's say, if I multiply by 3 halves, then this will be 3. And 3, okay, how about multiplying by -3 halves? Okay, so we need to experiment. 3 plus, if we multiply this by -3 halves, then we get -3, and 3 plus -3 will be 0. So R4 plus, multiply R2 by -3 halves, because 3 plus 2 times negative 3 halves means 2 cancel. 3 plus negative 3 means 0. Okay, that's how we get 0. So, or we could have multiplied second row by 1/2. Multiply by 1/2, that would have then 0, 1, 1, 0, 0. Okay, that then it would be 1. Then we could have multiplied by negative 3. Okay, so there is an option, but let's do this one. Okay, so here now we are leaving first 3 rows as it is. 0, 2, 2, 0, 0, 0, 0, 1, 3, 1. Here 0 times any number, 0 plus, we are multiplying here, right, R2. Okay, here's 0, so 0, this is 0. 3 plus here, negative 3 halves times 2. Okay, that's 0. That was our design. Now 2 plus negative 3 halves times 2. 2 to cancel. 2 plus negative 3 is negative 1. Now negative 3 plus we multiply negative 3 halves times 0, just 0. And negative 3 plus 0 is just negative 3. Now negative 1 times, again 0 changes, does not change, so negative 1. Okay, we are almost there. Okay, we have to make this augmented matrix triangular. And here is now, we are here, okay, 0, 0, we have to make this 0 and we are all good, because then this will be triangular. Okay, still working on R4. We have to make this 0. Oh, here is 1, right, because 0, 0, 1. So R4 plus, simply add R3. Okay, first 3 rows are same. Not changing. R3, 0, 0, 1, 3, 1. Okay, now R4 plus R3. Okay, we are adding R4 with R3. 0 plus 0, 0, 0 plus 0, 0, negative 1 plus 1, 0, negative 3 plus 1. Oh, negative 3 times, negative 3 plus 3, sorry, 0, negative 1 plus 0. Oh, all 0. Now to see if this has a solution, we can convert this back to in putting in terms of variables. Let's make equations. Okay, so this one was from this one is in fact, okay, pretty much 1 x1 x2 x3 x4 minus 2 x4 equals negative 3. Okay, we didn't change anything. And this one is 2 x2 x3 plus 2 x3 0 x4, so 0. Third is x1 x2 x3 plus 3 x4 equals 1, and everything 0. there are nothing. And if we look at this closely, so we got from here, if we look at closely, we can, from the third equation, we can solve for x3, right? x3 would be 1 minus 3 x4. And when we can plug in x3 here, then we can solve for x2. Okay, that will be in terms of x4, and plug in here, then we can find x1. By the way, there are 4 variables and we got 3 equations. So we'll learn in next section. In this case, there will be infinitely many solutions, but this is good. So we have a solution. That means the system is consistent. Okay, sometimes while doing this type of work, we end up getting 0, 0, 0, and let's say it's a 4. If we had this situation of everything, then the fourth equation will be 0 equals 4. That's not true. In that case, there is no solution. The system would be inconsistent. but we don't have that situation. Okay, so this is, we have all zeros, so this is good. We have equations, so 0, we don't have to write anything, triangular, and we can find solution. And in the next section we'll learn there will be infinitely many solutions. 4 variables but fewer equations. So the system, the linear system, has at least one solution. That means the system is consistent. That's what we want to check. Consistent. Final.